Now we're going to start introducing the basic rules of probability, starting with the simplest such rule, which I'm going to call the obvious rule of probability. The obvious rule of probability basically says that either A or not A must be true. We write the probability of A plus the probability of not A is 1. I have chosen to call this rule the obvious rule because it seems obvious. However, keep in mind that it is not actually true for all logical propositions. As a matter of fact, Gödel proved that any system of logic that can count contains propositions that are undecidable, and in this sense there are propositions that are neither true nor false within a particular axiomatic system. In any case, we're not going to be concerned with such propositions. A very nice way to think about the obvious rule is to utilize the Venn diagram, which you see right here. The Venn diagram visualizes all the possibilities that are allowed by our background information, and these correspond to the blue square here. So A in particular, which is one set of possibilities, is depicted here by a green square. So not A is basically everything else that you see right here. And of course you see that A and not A make up the entire I, so one of them must happen. Let's apply the obvious rule to a very simple example. This is a classic example of probability. It's essentially a box containing two kinds of balls. Here we have 4 blue balls and 6 red balls. And this information essentially constitutes I. What we're going to do is we're going to draw a single ball and we're going to ask what is the probability that it is red or blue. Now on the right you see the graphical model representation of the situation. You see that the number of red balls and the number of blue balls determines the first draw. Of course here they do not determine the first draw deterministically, but they determine the probabilities of the first draw. Alright, now consider the logical sentence B1, which is the first ball we draw is blue. And let's compute its probability. We have 10 balls in total, and out of these 4 are blue. Therefore the probability that we should set is 4 divided by 10. The principle I use to make this probability assignment is the principle of insufficient reason, which was first articulated by Laplace. Now that we know the probability of drawing a blue ball first, we can calculate the probability that we're going to get a red ball. Of course, a red ball is simply not. So the probability of a red ball is the probability of not a blue ball, which is of course, using the obvious rule, 1 minus the probability of a blue ball, which is 1 minus 0.4, which is 0.6. And of course this is consistent with the principle of insufficient reason, which would find that the probability of a red ball in the first draw is 6 divided by 10, because we have 10 balls in total and 6 of them are red.